Hello, I am David W. Parker, and this is Programming Today I Learned Algorithms, and this is episode 3. Today we're going to be looking at the heap data structure. Next time we'll be looking at heap sort, which uses a heap data structure. So what is a heap? A heap is basically a nearly complete binary tree with a couple of special properties about it. Really just the main heap property, so to speak. And what that is that if it's a max heap, then the parent of any parent and children has to be a larger value than any of the children, and if it's a min, it's the exact opposite. So let me just show you an example here really fast. So here's an example of heap as a binary tree. The parent, 16, is more than the 14 and the 10. The 14 is more than the 8 and the 7, and so forth. The 2 and the 4, the 7 is larger than the 1, the 10 is larger than the 9 and 3. So this is an example of a heap. This is actually an example of CLRS, and so what we're going to do is we're going to go through and implement something called max heapify, which will take an array and it'll spit out that exact same example as you saw, and then we're going to have another function here called build max heap, which takes an array and runs through the entire half the array there and max heapifies each of the ones as it goes down. So let's just go ahead and run this real quick. And so you can see here is the initial data structure, or the initial array that's given in CLRS. And so 16 is currently a parent of 4 and 10. 4 is currently the parent of 14 and 7. 10 is currently the parent of 9 and 3. And this is kind of hard to see, but you could see a heap as an array. This is the way it's built out, so you can kind of see how it looks. It's kind of hard to tell, but as you get used to it, you'll be able to see it a little bit easier. So in the example given, we have this, and we swap out 14 and 4, and then we swap out 8 and 4, and we end up with this final array, which is identical to this one right here. In the example, this is umd.edu, so I'll make sure to include this in the show notes. And so that's kind of nice. And then we have the build max heap, which iterates through, and this one actually goes ahead and it'll continuously be using the max heapify function, and by the end you'll end up with a max heap. So let me go ahead and show you this is a really poor picture from CLRS because I couldn't find the actual example, but this is the one we're printing out. So this is the initial array that we're given, and you can see what's going on. So we're going to start right in the middle here, and when we look here, this is what this is doing. We're starting in the middle, and we're going to iterate down. So 5th element, 4th, 3rd, 2nd, 1st, and then we'll be done. So we're going to iterate down, and we're going to max heapify each of them. So starting here, we can see this is already a max heap, so it is fine. Moves on. 2 and 14. 14 is obviously bigger than 2, so we're going to reorder that, and that's where we're going to end up here. 3 is obviously not as well, so 10 will come up here. Now we're here on 1. 1 is less than 16 and 14, so 16 is going to come up, and then this will still be a max heap. 1 will get pushed down here, and then 1 will get pushed down here. That's what max heapify does. We'll show you that in a second. Finally, we're on the last element, which is 4, and then that'll get pushed down all the way down to here. So it's less than 16, it'll get pushed up. It's less than the 14, 14 will get pushed up. It's less than the 8, 8 will get pushed up. And then that's what we end up with. So you can see that output right here, 16, 14, 10, 8. So we have 16, 14, 10, 8, 7, 9, 3, 2, 7, 9, 3, 2, 4, 1. So sorry for the poor quality of the pictures. You can pause the video if you want to take a look at that a little more detail. So that's what build max a heapify does. Is it'll build that max heap for us. So let's go through max heapify real quick and just kind of break it down just a little bit. So you can always find the left and right node by multiplying by 2 of the current index and then adding 1 or 2. So you can always figure out here that, if what the left node is and what the right node is. The reason we're not just doing ×2, we're doing ×2 plus 1, is because JavaScript indices start at 0. So getting back to the code here, we're going to set the largest as the current one actually, and then the left and the right. And this is basically saying, hey, if the left is less than the size and we have the left value is actually larger than the right value, the largest value, go ahead and reset the largest. Same with the right. We'll set the largest. If the largest is not the current index, then exchange them and swap them out, and then run the whole thing again. And so that's what pushes each individual node down the tree. And so what we do with this is this will push each node down the tree. And max heapify, I wrote some notes here from CLRS, it assumes that the left and the right are already max heaps. And that's why we have to have this separate function here that iterates through each of them and walks up the tree starting at the halfway point. This allows us to have a single node get pushed all the way to where it needs to be, and it floats down, so to speak, in the max heap. And this builds our way up, so we have each value float down, and then this builds the rest up. So the total running time on this is, I believe, O of login for the max heapify, and the build max heap runs in linear time. Next time we'll see that the heap sort runs in login time. But that's it for now, and I hope you enjoyed this episode. We'll be using this heap in several other data structures and several other algorithms in the future. If you like what you saw today, please subscribe. Thank you.